different graphs. So we're a lot of this chapter does deal with graphs. We're going to look at some absolute value graphs as well. And then kind of reviewing. There's a teeny bit, but nothing like last chapter.
I can do that.
Thank you.
I enjoy this.
So if you look on the packet that says Unit 7 homework, you can see, let me see here really quick.
I don't really feel like it.
What is a brown nose? I'm so confused.
What?
I'll explain it when I'm not recording.
Okay.
Oh. Okay, so we talked about all of these graphs, or almost all of these graphs so far this year. We've graphed linear functions, y equals mx plus b. We've graphed quadratic functions. First semester, it's been a little bit, but we've graphed a cubic function.
I wasn't here.
You've done it before, though, I promise. You've graphed a quartic function, where their exponent is 4. Exponential functions, that was the beginning of this semester. Logarithmic, we also graphed some logarithmic equations. This chapter, so actually on Tuesday, we're going to graph some absolute value functions, and of course we graphed sine. I didn't put cosine on here.
This is the first time we're going to be allowed to have these on the graph.
Yes, you are going to be allowed to have a V, and it's for your.
Is that why we try so hard to not make it look like a V?
Yes. Yeah. Why we want to make sure that these don't look like these, because they are two different things. So what we are going to be doing, we'll start with piecewise functions today, which basically just means we're going to take pieces of each of these and kind of put it together. And then
this is a short chapter.
Tuesday next week we'll do absolute value functions. And then we have, hold on, let me finish my train of thought. Thursday next week we'll be doing 7.3, which is systems of equations. System of nonlinear equations. So you've done a system of equations before where it's just two lines they cross, you look for the point that they cross at. We're going to do the same thing, but we're going to have maybe a quadratic graph intersect with maybe a linear or maybe a exponential or logarithmic graph. So we're going to see what happens, like how many points of intersection there are, and those points of intersection would be our solutions. So look at it a little more. And then the last part of this chapter is, and this is the reason why I put all these pictures on here, I'm going to give you some information, like a table of values, and you're going to use your calculator, because we're not going to make you do this by hand, because that would be awful. But based on the table, we're going to have you guys decide which graph it goes best with, and create the equation based on that. The calculator will do a lot of it for you, but you're also going to have to use your brain a little bit to decide which graph the data fits best with. So it's kind of a big review of this whole semester, and really kind of this whole year, to see how data trends and how you can see, like, as things keep on going, what would happen, what do we expect. And so that's really a trend line that we see a lot of with lots of things. So any type of business deals with trend data and trend lines. What's your profit versus your expenses? All of that kind of stuff, that's something that you see a lot of. So we're going to be kind of using that to help make predictions with information. So that's kind of what this chapter's about. It's really short. Today we do have a 7-1 assignment. Tuesday we are going to have a short 3-question quiz. We're calling it a mini quiz. 3 questions just over our piecewise functions. And then we'll do our notes on 7.2 absolute value. And then on Thursday, you'll have another 3-question, very short mini quiz, just kind of making sure that you know how those functions work, because we really don't have time to do one big quiz, because there's only 4 sections here, so it's really, really short. So we just are going to do these little mini quizzes, and then we'll have our review. So this would be, I'm trying to think what would our, I need a calendar. And drive. I was like, where's my calendar? So this chapter, just so you guys kind of can see where we're kind of pacing out, we would test on this chapter, I believe it's on the Friday before senior's last day. So this would be the last chapter for Alexis. Let's see, there's our calendar. Like, I've got all the different years depending on how things went. Maybe. Try again. Thinking about it. Come on. There it goes. Okay. Watch, I'm gonna have like 4 of them open. So here's like our whole year. All those orange ones are the days that we were remote. Like, everybody was remote. Yeah. All those Wednesdays, you remember that? Isn't that crazy?
Yeah.
So here's kind of where we're at. So there's our 7-1 on our B day on Friday. So 7-1 mini quiz and 7-2 on that Tuesday. That's also the makeup SAT if you missed it last or when everybody else took it. Then 7-3 on Thursday next week with the mini quiz. 7-4 on the Monday, May 3rd. And then we do start getting into our AP testing. I know, I'm not sure if that's totally accurate. I think that's from a previous year. I have other dates for that. And then we'll review on the Wednesday and we test on the Friday. And right here is senior finals these 2 days. So, yeah. Pretty crazy. And then
My B day, or my A day, I only have to come for 4th hour.
And then our chapter 8, just so you guys can see there, chapter 8, we have 1, 2, 3, real short, 3 sections. We're not even going to test on it. We're just going to take a quiz. It'll probably be a group quiz even. So,
How
yeah.
are my finals
And
gonna,
then-
or how is my final gonna look for here?
I don't know. I haven't written it yet.
I think you should just pretend you gave it to me and just give me a 94% just to make it look believable.
Oh, right, yeah. Okay. So let's get started on our piecewise. Part of the reason I'm not necessarily worried about taking too much time because we will literally be done with these notes in about 25 minutes, not even. So we're going to have tons of time today, which is not necessarily a bad thing, especially because I know I have someone who has to finish their test.
I wonder who it is.
And Aubrey, we have to figure out
You already
when
called
you're going
them
to
out.
take your test because you missed that last class too. So, and Olivia, same. Okay. So, piecewise functions. So really what a piecewise function is, it's pieces of different graphs. So we're going to start with a nice, quick, easy one. So I had a little word problem here of how piecewise functions work. Okay, so explaining
It's
why
a
we
word
use them, what they're
problem?
for. They're not all word problems, no. It's just, I'm starting us with one because this is kind of a very basic idea of why we use a piecewise function and what its purpose is for. So the cost of shipping a package depends on its weight in pounds. The table below shows how much it costs to ship different weights. So basically they have flat rate shipping here. So if it's less than or equal to 5 pounds, it's going to cost you $5. If it's more than 5 pounds but less than or equal to 14 pounds, it's going to cost $8. And if it's more than 14 pounds but less than 30 pounds, it's going to cost $12. So they're just trying to use a flat rate shipping idea in this. So what we want to do is we want to try and figure out how would that look on a graph and how would that equation, how would I write that equation to go with it? Okay, so what I can see here is I have 3 different circumstances. So I'm going to have 3 different equations based on the circumstances of that equation. And that table really kind of shows us how it's going to look. So the first thing it said, if it's less than or equal to 5 pounds, it's going to cost $5. So basically, oops, we got to realign. Hold on. Here I've been spending all this time on the board and I didn't even think to check its alignment. Alexis, where you at?
In my chair?
Oh, I thought you'd do this for me.
Well, don't you prefer me sitting in my chair?
I do prefer you sitting in your chair.
Exactly. Don't
Amazing.
complain.
As you should.
I'm going to turn that volume down a little bit. There we go.
No, it's okay.
Okay.
Don't complain anything.
So we know that it's $5 when the package is less than 5 pounds, right? So what we want to do is kind of write an inequality over here. So I'm just going to say X. When X, that's the weight of the package. You could do W if you want, but because they're using X here, I'm just going to use X for my variable, is less than or equal to, so I'm going to put a sign underneath of it, 5 pounds. Okay, so basically we're saying on this graph, try again. On this graph,
Is this where we colored the things?
nope, you don't have to do that. So it's $5. So
feel
no
like
matter
we've done
what, you're going to pay
something like
$5. But do I pay $5 the entire time?
No.
No. If I'm thinking about this being a graph, this is the price, this is the cost, and this would be the weight. So how long will the price stay at $5?
Till 5.
Until it
It's at
hits 5. So I'm going to put like a circle there as my stopping point. I know that it's going to cost me $5 until I hit 5 pounds. And then what's going to happen? once I hit 5 pounds, what happens when I go over 5 pounds?
It's gonna turn into $8.
It's going to turn into $8. So I'm going to jump, the price is going to jump up to $8. Is that, no matter what, if it's more than 5 pounds, it's going to cost you $8?
Yeah. It's gonna be more than 5 pounds, but less than 14.
Good. So more than 5. So I'm going to say more than 5 pounds, but less than 14 pounds. Does yours just says less than 14? Does mine say less than or equal to 14? It does.
It does. Mine says
Yeah, it's because
less than.
yeah, yours just says less than. I'm going to use the equal on mine because there isn't an equal to 14 pounds. So like basically it's saying here, is there any circumstance, what if it's exactly 14 pounds? Is there a price for it? No. So I think I edited mine to make the less than or equal to, because otherwise it didn't work. So what would my graph look like now for the second part? Do I start it way back here at 0?
No.
No, where do I start it?
You go up to $8 first of all,
Yep.
and then you start at 5.
Yep. Now would I do a closed circle at the $8?
No. Yeah.
Or would I do an open circle? Am I including, when it's exactly 5 pounds, does it cost $8?
Why would you?
Yeah.
You would put it at 6,
Oh,
wouldn't
no.
you?
What's the price?
$8.
$8. So here's my question. If it's 5.1 pounds, does it cost $5 or $8?
$8.
It costs $8. So what I'm going to do is to show that it's not including the 5 pounds, but it is anything bigger than 5 pounds, I'm going to use an open circle. You guys remember doing open circle,
Are you at
closed circle?
6?
I am
Yeah.
at 6. Oops, sorry.
I'm so confused.
There we go. I'm trying to line up my. So there's at 5 pounds. I'm not actually
Oh.
including the 5 pounds.
This
That's
is
why
like
it's an open circle.
this is like the lines where you like, you know what I mean? They've got like the inequalities on the lines, and then you have to draw the line across.
From here to here, yes. So the inequality is not actually a shading inequality. It's just saying from this number to this number, draw your graph here. That's what a piecewise function is. So rather than making it, a whole line of 5, a whole line of 8, and a whole line of 12,
Oh Lord.
we're going to only do pieces of those horizontal graphs.
And then at the 14,
So yeah,
It would be a closed circle, right?
it would be a closed circle at the 14, because even though I know the words didn't quite match it on your paper, on mine it said when it's less than or equal to 14 pounds, it's still going to cost you $8.
so the next one would be $12.
$12.
And
Like a
then
stair
it would be
step.
It is. It's called a step equation when it's just these nice horizontal lines.
it would be 14.
And less than
Okay.
30. Now, obviously,
More
our
than-
graph doesn't go up to 30, but we can kind of
X,
estimate. So yeah,
Go to the
but
end.
less than. Hold on.
yeah. So more than 14. So again, even though this is a less than symbol, technically, we're saying it's more than 14. So, alligator eats the bigger number. X is bigger than 14. That's what this is trying to tell us. But X is going to be less than 30. And then we don't have a pricing scale. It probably goes into individual pricing beyond that. They don't have flat rate shipping for anything over 30 pounds. So now, my $12, I'm not going to start at 0 pounds for $12. It only starts costing $12 once I hit
14.
that 14 pounds. And I don't include the 14 because the 14 would be filled in here. And then I would just kind of keep this going up until it hits 30. And it even says less than 30, so I'm not even going to put an open circle. I'm just kind of estimating here. Because obviously my graph doesn't go all the way to 30. The reason that we do this is because that way, if we were to put these all, if we were to kind of shrink the pricing, or put all of these together, oops. Can you tell I've done this? Hold on. I'm just going to get rid of that one. Are all of these going to create one consistent line all the way across?
Yep.
Yeah. So the reason that we don't do closed circle and closed circle is because we can't pay 2 different prices at the same time. We have some closed circle and some open circle. So it's there to represent that it's not 2 different numbers at the same time. We only do it once. And then this one was my 12 way up here. We can't be 2 different numbers or 2 different costs at the same time. And so we're going to see that a lot on all of our equations and all of the things that we write. So this is called a piecewise function. It's pieces put together to create a graph that kind of helps us guide our eyes and kind of guide where everything goes. Okay, so it's basically just a pricing scale, depending on the situation. But just to kind of say, okay, well, if you're here, then you're going to pay this much. If you're, if you're a child, you don't pay full price. You pay, a smaller fee for children. Typically, you can go to a buffet or you go to an amusement park or whatever. Kids always pay or cost less.
Yeah. Like
Adults cost more. You get a senior citizen discount. You get a student discount. Like you have all these different things. That's basically just a piecewise function. So where we see these kinds of things in real life, we do see them. You don't think of them like this, but that's kind of where we see them and how they function. So what we're going to look at now, of course, we're going to put a little more algebra into it and start looking at, okay, now we've written a piecewise function. Can we, being given a piecewise function, interpret it? So kind of going the other way around. So let's take a look. So I have two piecewise functions here. It says evaluate the function for the given value of x. Okay, so what this is saying here is, here's x. They're saying evaluate it when x is 12.
So you just plug it in.
So we'll plug it in. Now, do we need to plug it into both equations? Into the 0.25x plus 6 and into the negative x plus 9?
No.
No. Okay? It just like this one back here. Did I need to pay $5, $8, and $12 for one package? No, it depends on the weight of the package. So if it was a 10-pound package, how much are you going to pay? Where would you find that?
You're gonna
If it was 10 pounds, what are we paying?
pay $8.
$8. I don't pay all three prices. I only pay one price. So I have to go based off of this information here. Tells me which function, which equation, or which a dollar amount I'm going to be working with. Okay? If they say anybody under the age of 10 eats free, and you're 11, do you eat free?
No.
No, you have to pay, right? So it depends on the criteria or the restrictions.
Something really bogus.
I know.
I went to this, I think it's kind of like Shogun, but it was in Wisconsin, and they had a kids menu, and there was I don't know, it was shrimp something on the kids menu, and I asked for it, and they're like, we can't give it to you because you're not technically a kid.
Oh.
And I was like, you can order a Happy Meal at McDonald's. I'm not technically a kid, but I can still get a Happy Meal.
Right, yeah.
It ruined my night. I was so mad.
I act like
It was orange chicken, I remember. And that was the only place they served orange chicken.
Oh, that's too bad. I'm sorry.
I was like, are you kidding me?
Like they wouldn't just make an adult-sized version of orange chicken?
My God, if anybody ever goes to Rhinelander, Wisconsin, please go to the Windmill. So good.
Really?
Ice cream is
Where
so
is that
good.
at?
Alexis, mask up.
Rhinelander.
All right,
Yours is hardly covering your nose.
So, with this, what we want to look at, we don't need to plug in x in both of these situations. We're saying x is 12. So which situation will will 12 be, work on this? So if I think that x is 12, is 12 greater than 3 or is 12 less than 3?
12 is greater than.
12 is greater than 3, which means I only need to focus
On that one.
on that top equation. I don't need to plug it into both equations. So just do one of them, whichever one the criteria is met. So because x is 12, 12 is greater than 3, I only need to work with the top equation. So this would be then 0.25 times 12 plus 6. And now I just solve that. I just simplify it. What's a quarter of 12? 12 divided by 4. 3. Plus 6 would give me
9.
9. There you go. There's your function. If you're actually writing it in function notation, not that I'm going to require you guys to do that, but if you're writing it in function notation, it would look like that, because that just means that it's the coordinate point 12, 9. That's where you would find it on the graph. All right, what about this one? This time, what is our x value?
-3.
-3. That's all this is saying, x is equal to -3. So which criteria does it satisfy?
The top one.
Yeah, is -3 less than -2, or is -3 greater than or equal to -2?
It's less than.
Good. Negative numbers on the number line, the bigger the number looks, if it's negative, the smaller it actually is, because you're farther from 0. So here again, there's our criteria. So what's g of -3 going to equal? Do I have a place to plug in x?
No.
No, so it's just 7.
Well,
That's
then
it.
what was that work for?
It's to know which one you're using. Is it always going to be the top one? No. It's just I happen to have a couple of these. Let's try one more here. What if I said g of 0?
For which one?
Well, it's g function, so the
Oh,
one that says g.
are we going off the numbers in the...
Yep, we're going off of this. So if I said g of 0, that means x is 0.
It's going to be the bottom one.
It would be the bottom function, so I would have to do -5 times 0, which would also just equal
0.
0. So g of 0 is 0. It's the coordinate point 0, 0. Okay, so the more you get used to just plugging the numbers in, it's based off of, though, what the requirement is, and then you plug it in from there. Okay, so you don't have to check it in both. That's, I think, the biggest thing people get stuck on. They just keep plugging them in. I'm like, no, you don't have to do both. Make it easier on yourself. Pick the right one. Pick one, but pick the right one. Okay, so now what we're going to do is we're going to graph these.
Oh, okay.
So, to graph a piecewise function, the easiest way to graph a piecewise function is just using a table of values.
-2, -1, 0, or 1, 2.
Well, do you see how your graph has like a bar that kind of splits them?
Yep.
That's
Let me
because
see
there
your
are 2
graph.
functions, and if I'm splitting it, what number am I splitting it at?
2.
2. So I want to know what's the value of the function when it's greater than 2, and what's the value of the function when it's 2 or less. Okay, so what I'm going to do, 2 is kind of like our asymptote, okay, just like our vertical. So I'm going to kind of use that. You don't have to draw this on your page, but I'm kind of using that as my guideline where the graphs should start and stop. So what I'm going to do then is I'm going to just plot some points for things that are greater than 2. Now I'm actually going to use 2 as my number, but I'm going to use an open circle because it doesn't actually say equal to 2. So if I'm going to use an open circle, I want x to be greater than 2, so that means I should use numbers that are 2 or bigger.
So 3, 4.
3, 4. So I'm going to just take those, and that's going to get plugged in then to the equation -3x plus 2. So I'm just going to evaluate those 3 table of values. So if I plug in 2, -3 times 2 would give me -6 plus 2 would make it
-4.
4. Good. Okay, so we're just plugging the numbers in. If I plug in 3, -3 times 3, 9 plus 2,
-7.
-7. 3 times, or -3 times 4 would make
-12.
-12 plus 2,
-10.
-10. So I would have, for my graph, I'm going to use an open circle on 2, on the point 2, -4, because technically I want to be greater than 2, not actually equal to 2. So I'm going to use an open circle on that, and then I'm going to be graphing to the right because that's where my numbers are greater than 2. So then I have 3, -7.
These are all closed circles too, right?
These would be closed circles, yeah. Why does it do that to me?
I don't know. Why does it?
I don't know. It gets all crazy and let me know. Like if it's over here, it's fine. But if it's on that side, it doesn't graph right. Let's see here. I had 3, -7. So these are included because this is in fact greater than 2. So I'm going to use a closed circle here. I only need an open circle on that asymptote because it said it was only greater than 2. Then I have my 4, -10. So my line would extend this way. Would I continue it up this to the on the right side or the left side of the asymptote? No, because the asymptote is kind of my dividing line.
Can you do 0, 1, 2?
So then, yeah, on the other side, I want to view this equation if x is less than or equal to 2. So I can start with 2 again,
2, 1, 0.
But now I'll do a closed circle for that. Maybe, if I can spell the word circle. C, then L, not LC. Circle. There you go. And then I want to go less than. So I'll go 1 and 0. Yep.
How did you spell circle?
I spelled it I was spelling it C-I-R-L-C. I was starting to spell it.
Well, your I looks like an R, so
Oh, yeah.
that's why I was confused.
I
No,
was
it's
like,
okay.
circle. Circles?
I don't know.
All right. And so this is my equation, and my equation is just x minus 1.
Hey.
So plug in my 2. 2 minus 1 is
1.
1. Plug in my 1. 1 minus 1 is 0. Plug in my 0. 0 minus 1.
-1.
So I'm going to graph those. I'm going to use closed circles for all of those now because it does include
2, 1.
So 2, 1, closed circle. That way I keep a continuous graph. I don't have a hole in the graph anywhere. 1, 0.
Crazy.
1, 0. There we go, 1, 0.
The other one's gonna be right there.
And 0, negative 1. Will I go up to the right or down to the left? Like beyond the red line?
No.
Down.
Down.
So it would just kind of keep going like this and have my slope of 1. It is a positive slope, but because we're only looking on the left side of the graph, it looks like it's negative. And there you go. That's how I graph a piecewise function.
I cannot draw a straight line.
Let's do another one of those because they're a little weird.
God.
They're not hard. It's just knowing you have all of these different aspects. The
It helps to draw
easiest
the
way-
asymptote. I can
It
tell you
does
that.
help a lot to draw the asymptote in there. If you don't do that, it's not a big deal, but you forget to stop otherwise. So big thing about an asymptote is that's your stopping point. Don't go anything beyond that. And you'll always know what the, look, I have 2 again. They're not always 2, it's just I happen to have that on here. They're not always 2, but it does just tell you where you're starting and stopping for your graph. It's almost the same equation even. It's a fraction now.
Oh god, really?
So it would be.
Instead of x minus 1, it's negative x plus 1.
So the top one would still be the 2 with an open circle and then 3, 4.
Yep. So we can still start with 2 with our open circle because it's greater than 2. So then 3 and 4. And then the bottom one we can do 2 with a closed circle
2, 1, 0.
and 1 and 0. Okay? Because it's x is less than or equal to 2. So the top one is for 3/2 x plus 2. And the bottom one is for negative x plus 1. And you could always set them up like that. So then, again, just to make it easier, you could draw that asymptote in. Just so you know, don't pass that line. Plot your points and go up 2, but don't go past that point, or that line. So I plug in 2. I have 3/2 times 2 plus 2. So 3/2 times 2.
5.
Oh, I was like, I thought you were saying 3/2 times 2 is 5. So like,
Did you steal my answer last
she just typed it in the calculator. Yeah, 3/2 times 2 would just be 3, and then plus 2 more would be 5. 3/2 times 3 would be,
5. Well, not 3/2.
yeah, this would be 4.5 plus 2 would give you, yeah, 6.5. 3/2 times 4 would be 8.
And 4 is 6, isn't it?
Yeah, 6
Yeah.
and then plus 2.
And then plus 2 would be 8.
Yeah, 3/2, yeah, because 3 times 4 is 12.
Times 4 is 8, and I was like,
Oh, yeah, no. Yeah, so 3/2, so I was going 3 times 4 is 12, divided by 2 gave me 6, and then plus 2, 6 plus 2 gives me my 8. Yeah. So on my graph, 2, 5. So I'm going to use an open circle again because it was a greater than 2. And then 3, 6.5 is part of the graph now. Everything would be included in that. And then my 4, 8, same thing. So I'm going to go up to the right like that. I won't go anywhere below 2 because that's not greater than 2 anymore. For the second graph, I've got a closed circle on 2. I'm going to plug into negative 2 plus 1.
Miss Kane.
What's that?
Screaming at somebody in the hall
Oh.
already.
Yeah.
Holy
It's Friday. All right, well, what's negative 2 plus 1?
-1.
-1. What's -1 plus 1?
0.
0. What's -0 plus 1? There isn't a -0, but so 0 plus 1? 1. So now I have 2, -1. I'm going to use a closed circle. That way I keep continuity. There we go. Okay, because that way there is still a 2 included in the graph somewhere. This is included, this is not included. We can't have 2 at the same time though. So that's why 1 has to be closed and 1 has to be open.
Are they supposed to always go the opposite way?
They don't always have to go the opposite way. It's just, that happens to be the case here. I was just trying to show you all the different kinds of graphs, what they can look like, how they can be. Can we write a piecewise function? So that's our next thing. Look at this, we're already almost done with the notes. This is it, we got 1, 2, 3 technically if we look at that.
We can start on mine too. We'll finish up.
I'm sure we can. All right, so let's see here. Write a piecewise function. Here's our function. So
It crosses at 0, 0.
yeah, we can see we've got
It's a closed.
asymptote
It's a
is
closed circle at 1, -2.
yeah. So we've got 2 things. I'm gonna write if instead of when, just because I don't have a ton of space. On your homework and on your quizzes and stuff, I already have this drawn out for you, so you don't have to draw your own.
We're supposed to write when or if?
It doesn't matter. They're the same thing.
Mrs.
Yeah, our
Johnson
asymptote we can see
disagree.
is definitely at 1. That's kind of where your dividing line is, right?
Yeah.
So that's the key thing here. So we know 1 is
So-
the key.
Yeah.
If we're looking at the first, do you want to look at the one on the left or the one on the right?
Left.
Right.
Oh, okay. Go ahead.
Doesn't matter. If we look at the one on the right,
It's just going straight across.
it's straight across at what number?
What?
At what number?
At what number?
Yeah, what number is the line on?
One
-5. So it's just -5. There's no slope to it. If, are we more than the asymptote or less than the asymptote?
We're
More than, because we're going to the right. So when x is greater than 1, and I didn't put greater than or equal to because, what kind of circle is it? Open circle. So because it's an open circle, I'm just using greater. So whenever x is greater than 1, our line is just horizontal. It's just -5. So then the other one must be when x is,
-2. X is greater than. I'm not greater than.
yeah, the other way. Yeah, what is our slope on that one? Or what's it doing?
It's inclining, but
It's going,
It's going up 2 but backwards 1,
Hmm.
right? So what's your slope if it's up 2 but backwards 1?
Two.
Yeah, it's 2 but it's backwards, so that makes it -2. Is there a y-intercept? Does it cross the y-axis?
At 0.
At 0. So do I need to write +0?
no, you can just leave it as it is.
There you go. There's your equation then. There's your piecewise function.
Sushi.
Is that terrible?
Yeah.
Yeah. Okay.
Math is terrible in general.
Oh, okay.
I promise I don't hate you, Miss Jan. I just don't hate.
Just don't
I
like
just
math.
hate the
We love you.
class.
We just don't like math.
I get it.
My
Okay.
teachers are brave. Okay?
Yeah, they
We'll give
are.
them that.
Yeah.
I could not teach this every day.
I
I'd probably
couldn't
cry.
either.
I'm kind of glad. Like they offered me when I first started. They were like, "Do you want to teach pre-calc?" And I went, "No."
No thanks.
Like I haven't done pre-calc in like 12 years. No, and not since I was in high school have I done pre-calc. So I'm not interested in trying to remember how to do that.
And then someone gets stressed out and they'll cry in your class, and then you can cry with them. So.
Yeah.
Yeah, it's okay.
Nick cried in pre-calc.
At least when it's like algebra 1, algebra 2, like I'm not trying to make anybody like that stuff that
You
I
know-
get. Like I just
Yeah.
intuitively I know
And it's
how
also
to do
like
it.
the first
Like-
basis math classes, and they're a lot easier.
Yeah.
Pre-calc is hard.
Like this is the stuff.
Nick
This is the
Yeoman thinks
basics,
it's
and then
hard,
once you
so
have the
it's hard.
basics down, then you go into these other classes. And I'm like, if I can get everybody to understand the basics, like that makes me feel better because I know they'll have a stronger foundation if they do decide to go on to a higher math class. So
You know what needs to happen?
What?
All all proms in general need to be canceled at this point.
I've heard there's a lot going on.
Oh
But we're
my
not
God,
gonna
there's
record and talk about that yet.
so much drama.
Did y'all see the Facebook post?
I'm
about
not.
some kid?
Oh, let's go on. So a plane
JJ, how'd you
descends.
You were supposed to say his name.
So a plane descends from 5,000 feet at 250 feet per minute
care.
for 6 minutes.
You really did him like that.
Over the next 8 minutes, it then descends at a rate of 150 feet per minute. Write a piecewise function for the altitude, A, in terms of time, T. What? Come again?
No.
Come on,
Huh?
say, huh?
Huh? Okay, so we're writing a function for the altitude in terms of time. So that's what all that is. And we have two things that are going on here. So I'm just kind of getting this sketched out. So I know I have two different pieces of information. And again, the reason I know I have two different pieces of information, it started at 5,000 feet, it descended at 250 feet for 6 minutes. So that's one piece of information. Then, over the next 8 minutes, it descends at a slower rate. So that's why I know I have two different rates, so I know I'm having two different things going on here. So let's think about this visually. We got a plane,
That's an amazing plane.
and
I
then
like that plane.
it's a pretty good plane.
I like
So right now this plane is at 5,000 feet, and it starts its descent. It's coming into the airport. It starts descending at a rate of 250 feet per minute. So I'm going to use T for my time, for my minutes. Okay? And it does that for 6 minutes. So then my next question is, then it's like the air traffic controller is like, whoa, hold on, we got someone else who's coming in first. You got to, slow down. Can't go at such a steep rate because we need to let this other plane start landing. Am I back to the 5,000 feet? No, I'm already lower. We got to figure out how much lower. And then from there, we're going to descend at a slightly slower rate at 150 feet per minute, and that's then for 8 minutes.
Okay, but I think Bessie was just like nose diving in the beginning.
It was going pretty steep, yeah. But at the same time, not so much when you're thinking about a plane and as fast as it's traveling through the air.
I hate planes so much.
I love planes, but
it's
I
so
always get the window seat, and it's
Okay, so the first thing we know, what are we starting at? 5,000 feet. That's easy enough. And we're going to descend. So we're going to subtract our height, 250 feet per minute. So that's our time.
Do you want to add the extra 0 on the 5,000?
Oh, yeah, I should add the extra 0 for 5,000. Here we go. Yeah, we don't want to start at 500 feet and descend at 250 feet per minute for 6 minutes.
No.
Because would that be bad?
Yes,
Yeah.
it would be very
it'd
bad.
be pretty bad.
that'd be like a hatchet story.
Oh God.
Okay, so this is when our time is what? Is this when our time is more than 6 minutes or less than 6 minutes?
More than or equal to?
More?
Less than
Okay, so how
Less
long
than
is
or
he
equal to?
descending? Is the he or she, the pilot,
Or
descending?
6 minutes. so
6
it'd be
minutes.
Less than or equal to 6.
Good. Less than or equal to 6 minutes, they're going to keep that descent, that rate of descent.
Go.
Then,
So would it be x minus 150 since we don't know that?
well, so we have to figure out. So could we figure out? We could do this pretty
No, we
easily.
couldn't.
If we know it was for 6 minutes that they descended, could we figure out how far they went down? What their new height is? Yeah, we just plug in 6 here.
Oh.
Okay, so if I went, 5,000 minus 250 times 6, what would be the new height? Where are they
Hold
starting
on,
at?
let me put in my calculator. $3,500.
3,500?
Yep.
So now they're at 3,500 feet, and they're going to slow their descent down. So now at 3,500 feet, we're going to subtract,
Right? That's what it is.
150 per minute.
She looked at me like I was crazy.
No, I was just wanting to know, you're good.
I'm like, wait a minute.
Now, what's the time going to be for that?
8 minutes?
T equals,
I
let's
know.
say,
Is it greater
equal to 8 minutes.
Yeah, am I going to start back at 0?
No.
No, it's for when it's 6 minutes. And it's going to do this for 8 more minutes. Does that mean it goes from 6 minutes to 8 minutes? No, it's 8 more minutes. So what's our total time that's taken place from the time they started descending until the time they're done descending? 14 minutes. because we would just add our 8 minutes onto that. So that one's kind of tricky in the way it's worded out. Okay. So we got to think about it. It does help. That's why we do graphs a lot, because that's kind of giving us this idea of how is this working. Hopefully, either, well, we can figure out, are they going to be on the ground at 14 minutes?
Maybe.
I don't know. What's 3,500 minus 15? 150 times 14.
Huh?
Or do they still have, they might still have some descent time. Hopefully they're not coming into to land at 150 feet a second, or a minute. 3,500 minus 150 times 14.
1400.
Oh, so they still have another 1,400 feet. So they're not quite down on the runway yet. The question is, so actually part B, what is the plane's altitude after 12 minutes? So have they landed after 12 minutes?
Can
Hopefully
we
not,
just put
because
12
there's still another.
after that?
We just put a 12 in. Yeah, we just put a 12, just like how we did when we put in the 14
3,500 minus 150.
times 12. And that'll give us their height when they're all said and done. Or well, after 12 minutes. So how much do they still have to descend? Let's see here.
1,700.
1,700 even?
Yeah.
All right, so they still have another 1,700 feet to go. We don't know what their descent changes to after those first 14 minutes, though. So. All right. So that one terrible? Not so terrible?
Ready to go back to sleep.
Okay. Part
Some
B.
chicken.
I'm sorry. The next question. I got one more word problem here, and then we're all done. Like I said, this is gonna go pretty quick. One more application. A little tricky here. Not terrible though.
That's terrible.
A salesperson, yeah. Earns 6% commission on the first $40,000 in sales, and then 10% on sales above that amount. So we want to write a piecewise function for the total commission C in terms of the sales S.
That's in the
Yeah.
thing.
So the commission based off of their sales. So how many functions am I dealing with here?
Two.
Just two. 6% and 10%.
You can have more than two functions.
You can,
Are we going to?
possibly.
Or you can just say yes, because you know it's coming.
Yeah, well, and again, I told you guys, like, I'll already have it set up for you, so you'll know how many functions, how many pieces you have to put together, so. Okay, so the first part's the easy part. They earn 6% on the first $40,000 in sales. So now, here's the thing, how do I do 6% as, like, when I
turn it back into a decimal.
turn it back into a decimal? Yeah,
2
6%.
points to the left, it's gonna be 0.06.
There you go. So they earn 0.06. I'm gonna write S. Try to make it not look like a 5. I hate when I put S's in word problems.
I can't. Yeah.
I know. I'm like trying really hard to make this not look like a 5. And that's if their sales is less than or equal to $40,000, right? So they earn 6%. That's the easy one. Then it says above $40,000, they will then earn 10% in sales. So they still, no matter what, they earn 6% on their first $40,000 in sales, and then if they get, I don't know, $48,000 in sales, they earn 6% commission on the first 40, and then they earn 10% commission on that last 8,000. That's actually how taxes work. It's called a graduated system. So like, when you go and do your taxes, most people either use someone or have a computer program that does it for them, so they don't have to think about it. Like I use TurboTax, like, so I don't have to think about it. But taxes are a graduated system. So you, like, if they say that they want to, you know, they're talking all of these things. They say they want to raise the tax rate on corporations to, I think it's 28% from 25%.
Wow.
That is not 28% flat tax. It's, they start with, like, I think it's, everybody does like 10% taxes, like people's taxes on your first 20,000 in income, like people, like I don't know what corporations are exactly, but so everybody pays like 10%. So on your first $20,000, you pay $200. I think that's 20%, or 10%, 2,000 for the year. Like that's what comes out of your paycheck.
Yep.
And then as your paycheck increases, then it's like from the 20,000 to the, I think it's 35,000, there's another tax bracket. So you pay a little bit on just that $15,000 difference. So taxes are really hard, which is why nobody likes to do them and why everybody really hated them before computers came along and started doing it for them. Because it was really hard to, like, you had to know how to break up your functions, how to do, okay, I only pay this tax on this part, and then from here to here I pay tax on this much for this amount, and then from here to here, and it just kind of keeps going up as a step function.
The fact that
taxes
if
are a
you make a
piecewise
mistake,
function.
the IRA is going to come from the IRS, not the IRA.
So that's what makes this one a little
IRA,
trickier.
the National Rifles Association.
Because it's not just on your sales alone. So we wouldn't say it's just 10% times S, because it's not in this situation. You only earn 10% on anything above $40,000. So we will still do our 10%, but that's only not on just your sales, but on your sales over $40,000. So how would I write that? How would I not count the first 40,000? I have whatever my sales are. So if I made $50,000 in sales,
Is it
S minus 40.
you'd have to subtract the 40,000 because that's calculated up here.
I can write really small.
I did write that kind of small. Let's see here.
Okay, so then
And then wouldn't the right side be S is greater than or equal to 40,000?
Yeah,
Or
No, not
greater,
equal.
just
Yeah,
greater
just
than.
equal.
yeah,
Just greater than.
just
if
greater
you
than.
have 40,000.
All right, Molly, I got it.
Now,
No, you don't.
Kidding.
I think
Literally
there
give us
is
the
one
wrong
more
answer.
thing I have to add to
And then I
this.
fixed it because I realized that I did it wrong.
So wait, hold on. So I think there is one more thing I'd have to add to this function though.
No.
So let's think about this. If I did this, if I said I made 50,000 in sales, that would be 50,000 minus 40,000. So I'd only get 10% on that first, on that $10,000, on that difference. Would it give me the percentage from my first 40,000 based off of this right here? No. So we also have to add in our 6% commission from that first 40,000.
I don't have enough room.
So that's a little trickier on that. Now, this one, you actually never see a problem like this again, where we have to break it up and do this graduated system. We do it here just because it is a really good problem that is very real world related, how things get broken up. A lot of people are like, dude, how come my paycheck wasn't like, as big as I thought it was gonna be? Well, it's because you didn't, like my sister is, her paycheck is based off of commission only. But she's done it for long enough that she knows how it all works. But the first time some of her salespeople come in and they're like, wait, I have this much in my sales this week. And she's like, yeah, but you get, your commission changes as, so they're like, how come my paycheck wasn't, 10% of the sales? Because you didn't earn 10% on the entire sales. You earned this much percent on this half, and you earned this much percent on that half, and then you have to put them together. So it's something that, yeah, it's
This sounds
weird.
stressful. What does your sister do?
She works for Denver Mattress, but she's one of the top salespeople in the country. So
Go
she's-
her.
Yeah, she makes
Bank.
bank.
Yeah.
Absolutely. Yeah. So yeah,
That's
I like
I'm
every
trying
year,
to
like
sugar
they
daddy
do
because
competitions
I
every
need to
year
make
to
it.
see like if you make so much in
not funny,
sales,
wait.
then you win a
It's a
trip.
profession.
So like every year she wins
Oh, my
the
dad.
cruise. So she gets a week vacation on top of her 3 weeks of vacation for the cruise. They pay for her cruise, everything but
Yeah.
alcohol. They don't pay for her alcohol.
How rude.
And she gets an extra like a week of paid time too, because they pay her even though she's on vacation for the company.
It's bougie.
So she's like, yes, yeah.
That's what my dad.
So
Like the top salesperson for
like,
Armstrong.
you sell
and-
mattresses for a living, and you're currently building, like she's building a $500,000 house right now. I'm like,
Go
you sell
her.
mattresses for a living. How is this possible?
Time to sell some mattresses.
I think
then.
our teachers should be paid in the millions.
Yeah, should.
You guys are.
I agree.
Really,
Well,
you guys
they're
work,
like designing
hard for
the
art.
future, and
Yeah.
they get paid less than.
And
Yeah.
my sister who sells mattresses.
That's crappy.
Go your sister.
Yeah.
I'm like, I'm proud of her, but I'm also like really
Jealous.
Question: why haven't you left here yet then?
Yeah.
Why haven't you left here yet? If she makes that much, wouldn't you want to go work with her?
I
No.
don't want to live in Indiana.
Because she might not make that much.
We don't have to live in Indiana.
Okay, wait,
to do that.
actually, let me see here.
She lives in Indiana.
Because this wouldn't be, I wouldn't, so this would be,
Eh.
oh, you know what?
If you
I
are
have-
telling me that is wrong,
It's a teeny bit wrong. this would have to be just times our 40,000, right?
Oh my goodness.
Because
Where's your
this would
whiteout?
account for the first 40,000, and then this would account for the everything over
Miss Ann,
that.
if you keep changing things,
I did. Well, I was like, wait, if I plug in 40,000, if I plug in my 75,000 here, then that wouldn't work, would it?
Like, wait a minute.
maybe your sister's.
I'm sure there's an easier way to do this, but that's just the way my brain made me do it today.
I just
You know how to
cannot.
write in pen.
Well, don't do that.
What kind of
It looks
Okay, so
easier.
let's see here. If I do this, commission on $75,000.
Huh?
If I have a commission of
Tell me that my pen
$75,000.
does not look
So
easy.
you
Am I only
put
doing this?
70. You'd put
No,
point
you're doing
10.
that thing.
Point 10,
Then you put 75,000.
75,000
Time
minus 40,000. Because you're only earning that
Plus.
35,000, 10% on that
Plus.
35,000.
Point
0.06 times 40,000.
Yeah, because that accounts for the part that you subtracted out.
I cannot.
I'm like, I'm sure there's an easier
It's-
equation than that,
I'm gonna
but
find it.
right now my brain can't do it. So let's just
Dang,
go with
a
that.
$9,860 paycheck. Tell your sister I'm going into sale.
Right? Yeah. Oh no, she loves it when she has good
Kidding.
weeks. Like her. Yeah, that's how she makes how much money she makes. So yeah, what was it? What was our total answer?
9,860. Unless I did it wrong.
Okay, I'll double check. So this is on her 35,000.
I got 5,960.
You got
Or
5,000?
I got 5,900.
Really? What did I do? Oh, I put 400 instead of 40,000.
Oh, okay.
Wrong.
5,900.
5,900. That's what I have too.
Thanks,
But
Alexis.
still, in 1 week, she just made almost $6,000. No wonder she
I'm
can afford
jealous.
that house.
I make $6,000 in 4 months.
Right?
Not even.
I'm gonna do sales.
Yeah.
now.
So sales can be,
Salespeople-
if you're a good salesperson, they can be very lucrative.
Okay.
I don't sell.
I don't know if
I
she
don't
actually
trust
makes 10%
salespeople.
on her commissions, like
Whatever
what
you
her
do.
sales commission
What?
is, but that's kind of how it works. So, what I think we should do, because we will have a quiz on this a mini quiz on this
Tuesday.
on Tuesday, let's add this to our yellow sheet really quick before we close it all up.
Yes. This is
No,
math
Molly.
class, and you
Tell
have
me what
put
to
in-
do. Again.
What are you doing?
Throwing my stuff.
That's so
Okay,
rude.
That was not supposed to roll like that,
Dude.
first of all. That was literally not even supposed to roll like that. It rolled vertically instead of just going straight down.
Imagine if we all had attitudes like Alexis. This class would be
Isn't
so
straight down
angry.
vertically? Do you mean it rolls horizontally?
No.
No.
It rolled vertically, like the thing was up
Spinning
and down, rather than
like
Okay.
this.
Vertically.
Oh, it's fine. Okay, so let's just do this one piecewise function here because graphing I think is probably where people struggle with the most.
Oh, now you're confusing me. Stop.
I don't know. I didn't see it, so. And then on Tuesday we'll look at the absolute value. Okay,
Why'd
so
you say Tuesday like that? You're like, on
because I keep
Tuesday.
because Monday is the beginning of the week, but then I'm like, wait, B-Day is Tuesday, so I got to remember that it's
Ooh, did
not
you get-
Monday, but Tuesday.
Did you get like breast cancer
Next
awareness
Tuesday.
nails?
Huh?
Look at her nails. They're like
I like
breast
the
cancer
nails.
awareness.
Little
They're-
stickers.
Oh, they're stickers?
I don't do that. Yeah.
Oh, well, you
they're
could always
little-
go get them done.
Yeah.
Miss Kane, I'll bring in my gel kit and we'll have like a nail party.
Oh.
That'll be fun.
I'll do your
Oh,
nail.
okay.
All right. So
Well,
first of all, we know that
$80
2 is kind of our
I'm
divider, right? So I'm gonna kind of
not in
do
that.
2 as my asymptote. You don't have to draw the asymptote, but I do find that it's helpful.
So helpful.
Yeah, it actually is.
That I know that I should not go beyond the asymptote. You shall not pass.
Love that.
Okay.
Open circle 2, 3, 4.
Wasn't that the meme you showed us?
I
I remember
Yeah.
that really distinctly.
Yes. So we're gonna do an open circle, and then for greater than 2, we'll do 2, 3, 4, and then here we'll do a closed circle on 2, and then 1, 0. How imagine what happens when I actually change it like from 2 to 3 or 1 or -2 or
Oh my god.
won't that mess with you?
That'll be a crime.
Okay, if we do an open circle and we plug in 2, this is for the top equation, the -3x plus 9.
It's gonna be 3.
So 2 times -3 is -6 plus 9 gives us 3. 3 times -3 is -9 plus 0, or plus 9 is 0. 4 times -3 is -12. plus
No,
9,
it's gonna be
negative 3. So we'll do an open circle on 2, 3, 3, 0, and 4, negative 3. We'll go to the right because those are when x is bigger. So it's not, even though the graph is going downward, it's the x side of the graph that x's are bigger than 2. On the other side of the graph, we're going to do our x minus 1. So we'll do 2 minus 1, give us 1. 1 minus 1, 0 minus 1. So we'll do a closed circle on 2, 1, 1, 0, and 0, negative